Log on, tune in, find out. Another good idea from Cambridge.
And it's a great pleasure to introduce Professor Tim O'Connor, who is Professor and Chair of the Department of Philosophy at Indiana University and a member of its Cognitive Sciences program. So we'll have a talk in a couple of days related to that topic. And he's written a book on emergence, which we have a copy of on the bookstall. But he's also interested in theism and ultimate explanation, and he's written a book about that too, and how theistic explanations complement scientific ones and so on. And it's more that kind of topic we're getting into now with the cosmic fine-tuning, which I have to say is a topic after my own heart, so I'm looking forward to this. Thanks, Tim.
All right, thank you. I apologize if my voice sounds a bit scratchy. Against my better judgment, I allowed Jeff Schloss and David Locke to drag me up to a pub after all year. And I noticed that they were not here at 9 o'clock. Killian, the student here, he was out with us, but he managed to show up at 9, being a bit younger. But I'll try to do my best. All right, so here's my talk for today. Design reasoning, in the gap and at the limits. I like Thomas Aquinas' way of thinking about this topic, his broad sort of perspective that we should think of God as the cause of causes, the primary cause behind all so-called secondary causes in nature. And we look to discern God's causal activity sort of at the limits. We respect the integrity of the natural world, and yet we see God as a kind of complementary primary cause behind all of what science seeks to understand better and better over time. And so that's where we look for God, not in the gaps of current scientific understanding, but rather in some sense at the limits. We had some discussion of this business of God of the gaps last night, so I thought I'd put up here a quotation from Henry Drummond on that. Henry Drummond is an interesting fellow. He was a Scottish biology teacher, but for about 10 years he joined the itinerant preacher Dwight L. Moody, who many of you may have heard of, who toured in the United States and in Britain around the turn of the 20th century. Moody himself, of course, was no fan of evolution. In fact, he has a great line at some point where he complains about men who dig up old bones and dig up old carcasses and make them testify against God. Right? So Moody was no fan of evolution, but Drummond, being trained in biology, embraced evolution. He was a devout Christian, and interestingly, Moody was criticized for having this evolutionist on his preaching team, but Moody defended him. So it gives you an idea of, we have a picture of how Christians reacted to evolution, especially kind of revivalist Christianity that Moody represented. But while Moody himself rejected it, he saw it as a permissible way for Christians to think about human origins. But Drummond has a nice quote on this. I'm told, I believe I get this from, who's the great historian at Madison on creationism? Ron Nash. Sorry? Ron Numbers, yes, thank you. That Drummond actually coined the expression God of the gaps. It was a Christian who coined that term. And here's a quotation from Drummond. If God is only to be left to the gaps in our knowledge, where shall we be when these gaps are filled up? And if they are never to be filled up, is God only to be found in the disorders of the world? Those who yield to the temptation to reserve a point here and there for special divine interposition are apt to forget that this virtually excludes God from the rest of the process. If God appears periodically, he disappears periodically. If he comes upon the scene at special crises, he is absent from the scene in the intervals. Whether is all God or occasional God the nobler theory? Anyway, I thought that was a nice quotation. And he's referring, of course, to this long and discredited history of attempting to find God in the gaps of current scientific understanding. A better approach, which has an equally long history, is to try to give explanatory arguments for theism that begin from what appear to be, in principle, built-in limits of science. So our question is, when basic science were to complete supposing it were to complete its task, is there be anything about the world and its workings that would necessarily remain unexplained, even if we had completed scientific theories? Something that an intelligent supernatural designer would explain reasonably well. Well, we will explore today just one such target of explanation, one that, unlike some traditional philosophical arguments, is rooted in particular results of modern science, in this case physical cosmology. For that very reason, there is an inbuilt provisionality to the conclusion of this argument, and that's a point that I'll return to later. And I should say at the outset, I'm not here to either defend or refute this style of argument, other than to try to get us to think better about this sort of argument. It raises really interesting issues. I think there are a lot of bad objections to a form of argument that some people have developed, and I want to expose the weakness of that reasoning. But I'm not going to tell you how to think about it. I have further thoughts beyond what I'm going to talk about here. I just want to help us to think a bit better about that and then open it up for discussion, and I'm sure some more objections will emerge in the course of our discussion. All right, so beginning, and apologies to those of you who know this science much better than the sort of very simple, sort of almost cartoon-like version that I'm going to give of it. But beginning around in the 1960s, a guy named Brandon Carter and others began to notice that several physical laws and other basic features of the universe, for example, the precise ratio of certain particle types, are fine-tuned for the eventual development of life. This has caught the attention of many cosmologists, astronomers for some time. So, for example, the British astronomer and religious agnostic, Fred Hoyle, remarked, "Such properties seem to run through the fabric of the natural world like a thread of happy coincidences. But there are so many odd coincidences, essential to life, that some explanation seems required to account for them." All right, so here are some representative fine-tuning claims, subject to correction by people like Ian, maybe the details, but these are things I've picked up in various discussion. And I don't think it's so crucial that we know the exact fine-tuning claims. There are a whole bunch of them out there. And just give you a sense of the flavor of what we're talking about here. So people will claim that, based on our current physical understanding, if the initial explosion of the Big Bang had differed in strength by as little as 1 part in 10 to the 60th power, the universe would have either quickly collapsed back on itself or expanded too rapidly for stars to form. In either case, life would be impossible. So it seems like the strength needed to be pretty much just what it was. Another example of a fine-tuning claim you'll encounter. If the mass of neutrinos were 5 times 10 to the negative 34th kilograms, instead of the actual value of 5 times 10 to the negative 35th kilograms, the additional gravitational mass would have resulted in a contracting rather than expanding universe, making life impossible. Third claim. If gravity had been stronger or weaker by about 1 part in 10 to the 40th power, then life-sustaining stars like the sun could not exist, making life impossible. Okay. These are the sorts of claims one encounters in discussions of fine-tuning. What do these numbers mean? Catherine alluded to this. Anytime you hear a talk by an astronomer, they always talk about the difficulty of the human mind to appreciate scale and the difference of a time scale of 10 to the 6th power versus 10 to the 9th power, and the kinds of processes that can take place in that larger time scale. But the human mind wasn't developed to deal with such large numbers, and so it helps us to have kind of concrete images to see just how large these numbers are. So, for example, I got this from one, I think, responsible discussant claiming to have done a back-of-the-envelope calculation, and this person said that to differ in 1 part in 10 to the 40th power can be imagined in this way. Cover the North American continent, the entire continent, with dimes, little coins, and then stack coin upon coin until you reach the moon, 240,000 miles away. Do the same thing 1 billion more times. Now subtract 1 dime. The difference is 1 in 10 to the 40th power. And so you go, oh, wow, that's really really minute. Here's a slide from Max Tegmark, an article that's often discussed in Scientific American, where he discusses this sort of phenomena. And here, this is just a way of representing the narrow constraint for life to be possible, posed by just two of the basic features of the universe. So it's represented as a kind of two-dimensional space, along which the strength, you see, of the strong nuclear force and that of electromagnetism are allowed to vary, right? And so you have different regions depending on what the values of those strengths might be. And for various reasons, these large colored components give you large-scale reasons why life would be impossible if the values were to occupy those regions. I won't go through all of that. So the small black region, you see that little thin band going in the bottom left quadrant, it alone is consistent with life. And then when you add in other fine-tuning requirements, you narrow the required value further still. That's why you see the dotted line. That would be if you impose certain other additional requirements. Okay, so the idea is, and there we are in that tiny little region, just necessary. Our universe has more or less just what it takes for life to be possible. So then, all right, that's interesting. It's striking to a lot of people. It struck Fred Hoyle, strikes a lot of physicists. How can we explain the existence of such a fine-tuned universe? Is it the result of some law of nature? Is it a result of chance? Is it just we won the cosmic lottery? Is it the result of cosmic design? All right, here's Leonard Susskind, another religious non-believer, writing in a recent book in 2005, and you can see where he's coming from just by the title of his book. He writes, though, the real mystery raised by modern cosmology concerns a silent elephant in the room. He writes as a cosmologist. An elephant, I might add, that has been a huge embarrassment to physicists. Why is it that the universe has all of the appearances of having been specially designed just so that life forms like us can exist? This has puzzled scientists and at the same time encouraged those who prefer the false comforts of a creationist myth. In the past, most physicists, including me, have chosen to ignore the elephant, even to deny its existence. They preferred to believe that nature's laws follow from some elegant mathematical principle and that the apparent design of the universe is merely a lucky accident. But recent discoveries in astronomy, cosmology, and above all, string theory have left theoretical physicists little choice but to think about these things. Another quote from Paul Davies, who likes to talk about this stuff as well. I'll let you just look at that quotation. The punchline, that level of flukiness is too much to swallow. We've got to say something about this. All right? We've got to address. It can't just be left as, wow, our universe is exquisitely fine-tuned for life, and there's nothing more to be said about it. How does one decide this matter? Well, design arguments have a long history. Famously, Paley's form of design argument for the existence of biological life, that many have taken to be decisively refuted by the theory of biological evolution. But design arguments have a similar form, right? The first stage is to exposit some phenomenon that seems very powerfully to exhibit apparent design. Right? It seems to have all the hallmarks of being something that's designed. Right? Paley wanted to say biological organisms were a great example of that. Right? Just like a watch, if you found in the forest, right, exhibits the marks of design. You wouldn't think it got there by chance. So Paley wanted to say about biological forms of life, they exhibit this exquisite interworkings of the parts of any biological system. Apparent design, and Paley went from apparent design to designer. Right? And then the interesting question is, how do you get from apparent design, which we can all acknowledge, right, something that looks highly designed, to it probably was designed, right? And that's stage two. That's the important stage of the argument. All right. So we're not considering this argument. The fine-tuning argument has nothing to do with biological apparent design in biology, right? It's the cosmos as a whole, right? And that's a strength of the argument, that it seeks to go right to the foundations of the world. And I'll return to that, why that's a strength, and why biological evolution has nothing to say about this. Even though Richard Dawkins thinks biological evolution refutes this style of argument, he's confused about that. It may or may not be a good argument, but Certainly biological evolution has nothing to say about it. So stage one, the existence of apparent design. We might put it this way. We might express what looks like it needs explanation. The basic physical laws and boundary conditions, as best we can tell, of the universe are highly fine-tuned for the development of intelligent life, of persons capable of learning about the world through perception and gradual accumulation of knowledge, having an ability to make a difference to many aspects of their lives and that of others, having free will. Well, hold off till Thursday to see whether you have free will. Having free will to choose which differences, good or bad, to make, right? We think persons are a very striking thing, right? A very valuable thing. The kind of thing that if you're in the business of cosmic world designing, you might be interested in, right? And the fact that our world has, is set up pretty much just so at the foundational level to allow that to be possible for persons to appear on the scene. The suggestion is that looks like the kind of thing that might have been designed if there were a cosmic world designer. It looks like it enhances the plausibility of the hypothesis that there was a cosmic world designer. Okay, well, how does the argument go for that conclusion? The claim is, there are different ways you could represent the argument. I'm going to represent the argument this way. Apparent design is best explained. It's an inference to the best explanation. It's best explained by a cosmic world designer, as shown by a simple application of so-called Bayesian reasoning for theory confirmation. I'll explain that in a moment. Don't be put off by that technical sounding word, right? So we're all familiar with the basic concept of probability, right? Probabilities are calculated over a space of possibilities, and we measure it by the real number interval between 0 and 1 inclusively, right? So if, a fair die, right, six-sided die, there are 6 possibilities when we roll that, how that could land, right? So there are 6 possibilities. Only one of those possibilities is a 1, right? So the probability, we say, is 1 over 6, right? What's the probability that you get a 7? 0. It's not among the possibilities, right? What's the probability that it will be either 1 or 2 or 3 or 4 or 5 or 6? 1. Certain, right? That disjunction has to occur, right? There's no possibility in which that disjunction is not true. And that's what I express here. If there are n possibilities that are equally likely, the probability of each is 1 over n. All right. Now, so some of your scientists are like, oh, good, nice little equation, this compact information I can easily assess. And then all the humanists are going, memories of high school algebra classes, coming back to you, symbol phobes, as I like to call that when I teach logic classes. But really, this is really simple. And let's walk through what's being said here. We're just letting 3 claims be represented by letters, just for concision. K is intelligent life requires significant fine-tuning. That's an empirical premise. It purports to be based on physical theory. Okay? E is the universe has intelligent life. We know that. We observe that. Here we are, right? Okay? D is the hypothesis that there is some kind of cosmic world designer. And then, just in case you don't know, when you have these double greater than sign, that means not just greater than, but vastly greater than. Okay? All right, then the argument really just has 3 steps, and then by Bayes' theorem, which I don't want to walk you through, but you apply Bayes' theorem to the first 3 premises, and you get the conclusion. Okay, what are the premises? First claim. You see, it's saying it's representing the probability, a conditional probability, the probability of E given K and not D. The probability that the universe has intelligent life, given that it were true that intelligent life requires significant fine-tuning, and not D. There is no cosmic designer. That is approximately 0. That is, it's very, very, very small. That's the claim. That's right. Jeff's saying no, but he'll explain later on why not. But the conditional probability premise 2, that the universe would have intelligent life, given that fine-tuning again was required, and the alternative assumption that there is a cosmic designer, is not exceedingly low. In other words, the existence of a fine-tuned universe is not extremely surprising, given a cosmic designer. It's perhaps the sort of universe we would expect an intelligent, purposive designer to go for, one with little mini replica designers in it, right? At any rate, it's not highly improbable. That's all that really needs to be claimed here, right? Okay? And then premise 3, important. People often don't talk about the importance of premise 3, but it's crucial for the Bayesian reasoning to go through, which says that the probability of there being a designer, just given, K, our background knowledge that intelligent life requires significant fine-tuning, that is, without having considered the evidence of fine-tuning, is a lot greater. It might be very small, but it's still a lot greater than that minute conditional probability of there being life when fine-tuning is required and there being no cosmic designer, right? Why is this a necessary assumption? Well, think of it kind of roughly this way, right? It's like, think of evidence as sort of pulling you up out of a pit of low probability or bringing you down, disconfirming evidence. Well, if you're so far down in that pit, your probability prior to considering this evidence is 0.000000, something. And even if some evidence comes along that is more likely on the hypothesis than not, it might raise the probability, but you might be so far down that it doesn't yet raise you to a very respectable level. It might still be, when you conditionalize on this new evidence, the probability might still be fairly low, right? Okay? So it's important that it not be super low, right? At any rate, that it not be comparatively. The real question is comparing those two conditional probabilities, that the one not be that vanishingly small, that 1 in 10 to the 40th power, or even larger if you multiply the various fine-tuning constants or improbabilities against each other. Okay? Why might you think this is a plausible assumption? Maybe we can talk about this more in the discussion, but one reason to say that that's a plausible thing to think is, when you really think about it, there are only so many cosmic beginning hypotheses of a general sort that we can think of, right? I'm not acquainted with, at least of a rather general sort, I'm not acquainted with as many as 100, right, in the history of philosophical and physical speculation. But let's suppose that's wildly lower than the number that there actually are possible, we just haven't thought of. So let's suppose there's 1,000. How about 1,000,000? How about 100 million different possibilities? That would be fine. And if we just said it was the prior probability of theism, the interesting thing about this argument is that it could be 1 over 100 million starting off. And if you accept the rest of the argument, it would be powerful confirming evidence. Because the low probability of intelligent life on fine-tuning and no cosmic designer is way lower than 1 in 100 million. You might say, well, we're talking about minuscule probability. 1 over 100 million is one thing. 1 over 10 to the 40th power is a much, much, much smaller number, right? And it's the comparative likelihood that drives the application of Bayesian reasoning. Okay? So, the conclusion, by standard probability reasoning, you'll just have to trust me on that, the probability of there being a cosmic designer, given that there is in fact intelligent life, for which fine-tuning was required, is high. But we must read this carefully, even if you accept this. The argument concludes that fine-tuning is significant evidence for cosmic design. This is not an all things considered, it doesn't give an all things considered conclusion, right? The on-balance probability of there being a cosmic designer. There could be countervailing evidence that completely obliterates the significance of this. That's the nature of Bayesian reasoning, right? You continually adjust your estimate of the likelihood of a hypothesis in the light of new evidence. So it's just saying this one piece of evidence is pretty powerful confirmatory evidence for the hypothesis. That's all. That's all it's saying. All right. Some skeptical replies. I want to walk us through 3 main skeptical replies and then an alternative that's been bandied about the multiverse. What would the significance of multiverse thinking have on all this? And then we'll close and then we'll have some discussion. First skeptical reply. And these are all replies that are given by respectable people, right, in various places. Some are by scientists, some are by philosophers who talked about this kind of argument. So here's one. This is bad reasoning. Why? All possible outcomes are equally improbable on the chance hypothesis, on the hypothesis that are the totality of physical reality, however much that encompasses, just is. It's just a brute fact at the end of the day, right? The fundamental facts, whatever they might be, of physical reality are just brute facts. There's no cosmic designer, right? The many which do not sustain life are no less improbable than the few which do. Since any non-life sustaining possibility, were it actual, would not require special explanation, neither should this one, which, while life-sustaining, is no more improbable. Every possibility is improbable if there's a vast number of possibilities, right? So now, it's kind of hard to get yourself inside this reasoning because, of course, if we try to imagine a non-life-sustaining universe, because, of course, we couldn't exist in such a reality. So we're going to imagine a kind of disembodied angel hovering over, the surface of reality, but an angel who doesn't know that it's created by God, or maybe isn't, just kind of out there, right? doesn't inhabit the physical universe. And it just says, this vast, unending ocean of mud. That's physical reality. Nothing, it's very improbable. It's all because there's so many possibilities. But there's nothing special about it that cries out for special design. It's not something that cries out, design, I've been designed, right? That angel wouldn't say, I'll bet this universe was designed, because how likely was that? It was extremely improbable that should have come about by chance, right? So why are you saying in the case where we get the interesting improbability that we should conclude design? The rejoinder to this argument, I think this is a bad objection, because it's not improbability alone that drives the argument. If it were, this would be a good objection. It's not just the fact that a life-sustaining universe is improbable. For example, and use an analogy, poker. All right, so I'm playing poker with Jeff, and I'm dealing, shuffling the cards, seem to be doing it, and I get a royal flush, the highest possible hand, unbeatable hand in poker. Jeff kind of grumbles, and I grab the pot, and I shuffle the cards again, deal them out. And again, I get a royal flush. Right? Now, at this point, Jeff reaches for his gun. We're Americans, okay? He says, take your hands off my money. And I said, Jeff, what are you doing? And he's like, what are the chances that you fairly dealt that out? And I say, Jeff, every hand of poker is equally improbable, right? It's 1 over 52 times 1 over 51 times 1 over 50 times 1, very improbable. And then, do that again for 2 hands. But that, even if I dealt myself terrible hands, a 10 high, a miscellaneous hand, not even so much as a pair of deuces or something, right? That would have been the same improbability, but you wouldn't accuse me of cheating in that context, right? So shut up and let me deal, right? He's not impressed by that reply, right? Why not? Right? Well, because the improbable outcome in this case is suspicious. It's one that invites design reasoning. It's an outcome that would be favorable to me, and that makes Jeff reasonably suspicious. Another analogy, people often talk about lotteries. Well, somebody's got to win the lottery, right? If you do a fair lottery, it's very, very improbable. So suppose Ian wins the lottery. It would be foolish of him, although sometimes people do, to say this had to have been, God, did this, because how it was so improbable that I should win the lottery. And of course, the reasonable reply is, well, somebody had to win, and it just happened to be you, right? But now, if we find out Ian is the favored nephew of the lottery commissioner who did the drawing, now we get suspicious, right? Now, because in this context, right, there's a design hypothesis that is not so improbable, right, and that matches that particular outcome. All right, another reply to the argument. This is Richard Dawkins' reply somewhere. He says, hello. Haven't you been around, for 150 years now? There is a non-purposive evolutionary explanation of design, apparent design. We know we have a non-purposive understanding of why there are apparently designed this special phenomena you're calling attention to, namely life, an intelligent life. It's an evolutionary explanation, right? And as I said earlier, evolution is really not relevant. Our question is not, how did life come to be in the universe? We're not looking for an imminent, we're not, the fine-tuning argument proponent is not offering a rival sort of quasi-empirical argument or explanation for the existence of apparently designed life forms. Rather, the question is, why is the universe so exquisitely structured at its fundamental, non-biological level as to allow for the eventual emergence of living things? Why is the fundamental physics such as to make evolution even so much as a possibility? Biology rests on physics, right? And so you can't appeal, right? We're asking about something that's more fundamental, it's prior to biology. I give a Rube Goldberg espresso machine analogy here. The engineers in the room will know what a Rube Goldberg machine is. I go just Purdue University, 2 hours north of my university, is a big engineering school. They have an annual contest. Students are, the winner of the contest is the team that can design the most complicated machine possible to yield the simplest possible outcome. That is the most gratuitously complex machine to yield some very simple little.
It's a Heath Robinson in English.
Okay, a Heath Robinson. All right. So, suppose I were to walk in here and I've got the, some engineers to build for me this big contraption. Or I feign ignorance, right? I'm surprised. What's this? They wheel in this contraption. Okay, and it's one of these things with tubes that balls can go through. It's got a bunch of notches, right? Little choke points, juncture points. And we'll suppose there's 100 of these juncture points, okay? Or 50, let's say 50, get it more in line with the number of people say, how many fine-tuning constants are there? Well, of course, physics is advancing, but sometimes you hear the number 30, something like that. All right, whatever. You have a number of juncture points, okay? And they also, the second, and I'm looking and saying, what is this? And they bring in a vast vat filled with like ping pong balls, only all the balls are notched, kind of like imprinted the way golf balls are, only in a they're not identical. They're all slightly different from one another, okay? And I go, huh. And at the end of this machine is an espresso machine. I'm thinking, how does this work, right? And I just walk over and I grab one of the balls at random, and I stick it on the tray, and I just flip. Oh, and according to each of and next to each of the juncture points are little dials, and you have 100 different settings for each dial. And I just go, I don't know, 3, 8, 27, 2, go. I just set up all of these things. Got to do something. Put the ball on the tray, this kind of little input tray, and it makes its way all the way through. At the end, espresso comes out. I say, oh, this is really good. And I say, sorry, I'm out of time. I walk out. Okay. Renee says, he goes over, he grabs one of the balls, and he had like some coffee here too, and he puts the ball on the tray, and it gets stuck at the 5th juncture point, right? And he says, well, what if I change some of the settings, right? Can that help? And he finds it always gets stuck somewhere. So, okay, that's a bad ball. Let's go go back to the original settings. Those seem to be important, but let's get a different ball. And it turns out you can't put any of the other balls, or maybe just one other after you've laboriously gone through 10,000 of these, right? And you more or less have to have the settings exactly as they are. You find that you can, in some cases, you can wiggle it around 2 or 3 notches. In other cases, it has to be pretty much exactly that one. There's just one other number that'll do it, right? But it's very, very fine-tuned, okay? And now suppose I come back on Thursday to give my talk, and you all say, yeah, right. Like you're going, yeah, I'm going to say, what? You know? And you say, well, how likely is it that that would have come about? And I say, well, there's a physical explanation of how the coffee came out, right? To get an engineer to tell you about that, right? There was a process and everything. It'd be analogous to, there's a biological explanation for how intelligent life came about, right? But you're asking something more fundamental. Yeah, but how likely is it that this machine that you just happened to, that you just got lucky in hitting all the settings, right? And grabbing just the right input ball that would yield that outcome? That's very suspicious. Yes, there is an explanation for what happened in one sense, right? But that, things should have been set up in just such a way for that explanation to be applicable still seems to call for a further, different kind of explanation. Namely, you knew what you had to do. You were pretending you just grabbed the ball at random. You were pretending you were setting the dials at random, but actually you were told what you needed to do. All right, third reply. Of course, the universe is suitable for life. Far from crying out for explanation, it's the least surprising thing of all about our universe, right? Why? Well, if it were not so, no one would be here to ask the question of why it is so. So we should not be surprised. You should never be surprised that there's intelligent life, because that's impossible to be surprised about that, right? Because it's impossible for there to be someone for whom there isn't intelligent life, right? This unsurprising fact of our observing life is enshrined in the so-called anthropic principle. Now let me just say right off the bat, this term anthropic principle it's bandied about in a number of different ways. And there are legitimate applications I accept, of this notion in cosmology, right? But this use of the anthropic principle is fallacious, I want to claim. Right? The necessity, yes, the conditional, if there is intelligent life, then the universe must have what it takes to sustain intelligent life, right? That's virtually a tautology. And so that conditional claim is not at all surprising. There's nothing to explain. Right? Of course, it's just the right-hand side of the conditional is just simply stating a strictly necessary condition on the left-hand side. So there's nothing to be explained about the conditional. But the fact that that conditional claim is necessary does not imply the necessity of the condition, the if clause. There is intelligent life. We've been given no reason to think that that is somehow necessary, had to be that way. Right? So you can't infer the necessity of the consequent, that the universe has what it takes to sustain intelligent life. Do you see what's going on there? Okay. Well, we can perhaps talk about that in discussion. So I think this is just fallacious reasoning. As I understand it, Brandon Carter, one of the physicists who was among those initially calling attention to a lot of fine-tuning data in physics in the 60s and 70s, his response, he didn't draw any kind of design conclusion. This was his response, right? And I think it's just fallacious, just bad reasoning. Well, that's philosophers. Sort of these kinds of claims. All right. So if we're not happy with any of those replies, is there an alternative to a design sort of hypothesis? And some think, yes, there is. We can make sense of fine-tuning. We can not just ignore it, but we can make sense of it without appealing to cosmic design. For example, MIT cosmologist and really closet metaphysician, Max Tegmark. You must know Max. No? Not really? I guess not. You guys are physicists. You scientists are so specialized, right? So you're both physicists and you don't even know each other. Okay. So in his Scientific American article, he had a little box, cosmologists infer the presence, never mind his level 2, level 4 talk, that's just, he's got very, he really is a philosopher. He's got a much bigger picture here, but I just want to pick out the part of it that bears on this, the bearing of many universe hypotheses on fine-tuning. He says, they scrutinize the properties of our universe. These properties, including the strength of the forces of nature and the number of observable space and time dimensions, were established by random processes during the birth of our universe. Yet they have exactly the values that sustain life. That suggests, not cosmic design, but the existence of other universes with other values. So, if one person, right, if I just sat here and said, okay, I've got a fair coin, and I'm going to flip it 1,000 times, and it just so happened it came up heads. Did you say that? Yeah. Here? Okay. 1,000 times in a row. You think, that is so unlikely, probably it's not a fair coin. But if we have, 10 billion, if we get to 10 billion people, which we soon will, I take it, on the planet, and Bill Gates pays us all to engage in a little experiment, please flip a coin 1,000 times, we wouldn't be so surprised. I don't know if the numbers are exactly right, but if we have a large enough number of people doing this, we wouldn't be surprised if a few times someone actually got 1,000 heads in a row. We'd expect very few to get that, but it would be there at the tail end of the distribution. It would not be so surprising. We wouldn't require a special explanation. We wouldn't say, your coin must have been loaded, as we say, right? It must have been weighted. No, we'd just say, well, yeah, it's probably somewhere there's a good chance someone got 1,000 tails, right? But the vast majority, it's somewhere closer to a 50-50 likelihood. Likewise, the argument goes, if there are billions of universes, we should expect that at least one of them, and of course ours, since we're here, would be fine-tuned for life. Now, the strategy requires not just any old collection of billions of universes, actually maybe something like a Googleplex of universes. It needs to be a really large number for this to be a viable alternative. But also, it can't just be a large number of universes, but it must be a vast ensemble which, in the aggregate, roughly corresponds to a random sampling across what we take to be the full space of possibilities, defined by this, our universe's fine-tuned contingencies. Can you see why? Right? So in other words, suppose there are different ways of representing fine-tuning. You know, another one is to say, well, suppose you had a 2-mile long line, you know, a band, and you know, every little extremely thin band of light across that represents a possibility. It's a very, very large number of them. And then we got this one little lit up band that maybe corresponds to 2 possibilities, let's say, right? And that's, you got to be in that band to have intelligent life. Now suppose we had a googolplex of universes, and while they weren't all right in that band, they were all clustered right around that. That still would be rather suspicious, right? It'd be like somebody's trying to hit a target, but it's a really hard target to hit, right? And so they only hit the target, you know, some of the time, but all the possibilities, right? Rather, what we need is just a kind of random sampling. That would be, then it would no longer be surprising that you have a fine-tuned universe. If they're just sort of scattered all the possibilities, and oh, yeah, as it happens, 1 or 2 are right within the required region. Now, suppose this is so. Well, then Tegmark and others claim no causal or purposive explanation of this universe's, our universe's fine-tuned character is required. It is to be expected that there is one, or at least one, fine-tuned universe, and of course we can't help but observe one since we can only exist in it. All right, what do we think about that reply? Is that a good reply? Does it sort of say, well, here's an alternative, and now you got 2. You can go cosmic design if you like, you can go multiverse, and there's nothing much more to be said. Well, here, I want to say this. If one posits a vast array of universes that we cannot see solely for the only reason of avoiding a design inference, that seems not just grossly unsimple. I mean, you know, a huge number versus, you know, admittedly, cosmic designer, that's a pretty big posit, you know, in your ontology, but it's just one of those as opposed to an enormous number of alternative universes. So you might think simplicity comes to bear, favoring the one, but setting that aside, it seems arbitrary to just gratuitously suppose all of these universes causally unconnected to our own for the sole purpose of avoiding the design inference. And it's contrary to the kinds of basic values that undergird theory selection, I suggest, in science. It would be as if Jeff, Ian, after seeing me deal myself 2 straight unbeatable poker hands against Jeff, he walks up and he sees what happens. He sees Jeff get angry, and he says, "I know what's been going on. You 2 have been playing poker for a very, very long time, haven't you? Right? You've been going on and off. You've been doing this for years and years and years. And I'll bet, Jeff, you've had stretches, you know, where you were dealing and you won, you know, had amazing hands several times in a row, right? That would be a weird way of reasoning. In fact, I suggest that would be to commit a fallacy that has been dubbed the inverse gambler's fallacy. You know, the gambler's fallacy is, I've been losing 9 times in a row. How likely is it that I'm going to lose 10 times in a row? That's very unlikely. So I'm going to bet everything on this final run, right? Really bad reasoning. You know, as dice players say, the dice have no memory, right? So if each roll is independent, the probability of this 10th roll is, you know, of my crapping out, as they say, getting, you know, the losing roll of the dice is just as improbable as it would be on any other roll of the dice. Now, before I started rolling, the likelihood that I would do that 10 times in a row was perhaps very low. But you have to conditional. You have to update your conditional. As it happened, you did it 9 times in a row. So that's now, the probability of 9 in a row is now up to 1, right? Because it happened, right? And so now we're just left with the single case probability, which, while may be low, it's not so very low. It's no lower. You don't have better odds here, assuming you have fair dice. Right? That's the gambler's fallacy. Some people say there's such a thing as the inverse gambler's fallacy. And what's going on there is you are positing more unobserved data for the sole purpose of making unnecessary a special explanation of the observed data. Right? These other universes are not functioning to sort of explain something about our universe. On this way of multiverse reasoning, we're going to get to physical cosmology in a moment. This is not physical. This is someone who just says, okay, if our universe is fine-tuned, I'm just going to suppose there's this vast ensemble of universes all disconnected from one another, right? And it's a representative sampling across possibility space, and so I'm not so surprised anymore. I don't think there needs to be any kind of explanation at all for our universe being fine-tuned. Right? So this other data is not a theoretical posit to explain what you observe. It's positing data so you don't have to give a special explanation, to alter your perspective on the situation so special explanation no longer seems called for. Right? And that's bad way of reasoning. Right? Clearly, so in the case of Ian walking up to Jeff and I, clearly the more reasonable explanation is, or if he's not enough impressed by the improbability plus special outcome by 2 hands in a row, if he sees me do it again and again, at some point he's going to say, you're cheating. Right? He's not going to say, you've been playing poker for a very, 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 very long time. Even if that extravagant conclusion that he's offering is a theoretical possibility. Right? It's just not a reasonable conclusion to draw. All right, that's what I suggest. We're getting near the end here. However, there's more to be said. Cosmologists posit multiverses, or some or speculate about multiverse scenarios where there are many universes other than our own, not merely to avoid the design hypothesis. It's not just a kind of posit, right? Rather, recent theoretical physics is rife with speculative, but to me a philosopher, fascinating models on which the visible universe, from the Big Bang onward, would be just one of a great many universes that have arisen from some sort of primordial, pre-Big Bang condition, such as a high energy field having certain special properties, capable of generating, under certain circumstances, universe-like entities. Insofar as one of these models could conceivably someday provide a powerful explanation for certain otherwise unexplainable features of our universe, that would give us some reason to accept the hypothesis. Or at least I will allow. Far be it from me, the philosopher, to follow Nidal and Catherine in dismissing these ideas as unduly philosophical and untestable. That's not, persuasive, reason to reject a beautiful idea for me, Here, explanation comes apart from testability, and it would give you at least some reason, I say. If it really could give an elegant, as some cosmologists claim, elegant explanation of certain very general characteristics of our universe, the universe we do observe, right, by embedding it within this much vaster superstructure, it would give at least some reason. I'm not saying conclusive, right? It would provide some kind of evidence for the hypothesis, even though it's not testable, it's not practical, and so it's not satisfying Ian. But, and some, there are all kinds of multiverse ideas, and talk to Catherine and Ian and others for the details. Some conjecture that universes themselves may subsequently give rise to other universes, perhaps by some mechanism and associated with black holes. At least Smolin has suggested that. There's a lot of ideas out there, right? But I'm told, I'm really interested to hear if some of our more knowledgeable people want to say otherwise. The proposed multiverse models that we have themselves exhibit fine-tuning at a higher remove, right? At one level up. That is, most mathematically possible multiverse generating models do not allow for intelligent life in any of the constituent universes. The initial, whatever that primordial condition is, right? You can't just have any old primordial condition in order to be able to generate a life-sustaining universe, right? Things have to be pretty much, you have to set the parameters of that. They have to be just so. They have to have certain properties that are more or less just so. So I'm told. So it looks like, on contemporary theorizing, you haven't gotten rid of fine-tuning. You just have fine-tuning on a higher level. The multiverse is compatible with cosmic design. They don't have to be, they're not mutually exclusive possibilities. A cosmic designer could design a multiverse, right? It's also very, it seems, based on current knowledge, improbable to exist by chance, the multiverse that is. So if it were the case, why should we not infer cosmic design? Even if we had theoretical reason to suspect that there are multiple universes generated in this way, it elegantly would account for certain features of our universe, that would not be a reason to reject, all by itself, to reject the design inference. All right, final slide. So, I imagine the proponent of this argument saying, look, heads I win, tails you lose, for the following reason. There's either a single universe or there's a multiverse. We know there's at least one, so there's either one or more than one. If there's a single universe, I claim we have good reason to think reality is fine-tuned for life, but we have empirical reason to think that. If there's a multiverse, so far, our models suggest reality still is fine-tuned for life. Where fine-tuning doesn't imply there is a fine-tuner, right? It's just a description of things have to be pretty much just so. So, either way, reality is fine-tuned for life, and if that's a good reason to draw the inference of design, if there's no competitor hypothesis, cosmic design hypothesis at least receives strong confirmation from cosmology. That's the argument. As I take it, that's the best version of the argument. And now let's just open up the discussion and see what you think should be said.
Great. Thank you very much. Well, I think there was one. Yeah. Yeah. Go on. Barry.
What would be the what would your comment be on the probability space being not limited but infinite?
Right.
And
Good.
how would that change the argument?
Good. That is a problem, right? Because yes. So he said. So if the possibility space is infinite, not very large, very large, but finite, but infinite, these values can go to infinity. What does that do to the argument? Now, some have claimed, well, it destroys the argument. Why? Because you can no longer you can't apply the notion of conditional probability here. If all outcomes are equally probable, and there's infinitely many of them, their probability is not 1 over something, it's 0, right? And so we can't, we additivity and stuff, things break down. I mean, there is that problem with the reasoning, and my reply to that is surely that can't be. It can't be that the argument would work in a finite case, but then breaks down in the infinite case. That would be very, very strange. That would be like, right, so what to say about probability is a really hard problem. There are actually some people who try to do things with that. I'm not competent to speak to that. But it seems like it would be the wrong conclusion. That tells us we've got to have a modified, there's some intuitive notion of conditional likelihood here that we can't capture, we can't model rigorously mathematically for this technical reason. But suppose go back to the lottery case, right? And we find out that Ian is the favored nephew of the lottery commissioner, and there was 10 million possibilities. We're suspicious, and then we consider other cases. What about if there were 1 billion? Say now it's getting really suspicious. 100 billion. Boy, that's really, really suspicious, right? This is over many planets, right? It's this. We now have intergalactic travel and stuff, and this consortium. Everybody participates in this grand lottery, and people laugh about it. Yeah, I'll buy a ticket, but there's just no chance I'm going to win, right? Although he wins, and he wins this vast sum of money because of his uncle's action. And then we say, but now what if there are literally an infinite number of tickets? Oh, well, there's nothing to be said about that because probability is not well defined. That can't be right? So I don't know. I can't. Say, I'm not confident. I don't think there is a rigorous way of developing the notion of probability under these parameters for the infinite case. But surely that doesn't destroy the intuitive force. The argument should get stronger in that case.
Ted had a question, and then
Help me understand something. I have worked with the assumption that multiverse advocates are determinists. Potentials, there are no potentials that don't get actualized. Yet you associated the word chance with them. Could you explain what the word chance means in the multiverse scheme?
Okay, yeah. Right, so Everett, Everettian interpretation of quantum mechanics, right? It's not that we have these single case probabilities and just one of them gets realized and just a brute fact. All the possibilities are realized. There's branching, right? And all the possibilities get realized just in these branching universes. So that's what you're referring to. So there's a sense in which there's a kind of determinism. All possibilities get realized, and that's guaranteed or something. So in that sense, you could say there's a kind of determinism. But right, what's the notion of chance? The notion of chance here is not this sort of local physical one. What's the probability of a particular mechanism yielding this or that outcome or a plurality of outcomes? Rather, it's what's the likelihood that whatever the fundamental physical facts are of the Everettian universe, right, if they involve highly fine-tuned cosmic constants of some sort or other, or particle ratios in the very earliest stages of the universe, or something like that, and we assume things didn't have to be that way, that's an assumption of the argument, which we could talk about and choose to get into that, and we assume things didn't have to be that way, then in that sense they might have been otherwise if there's no deeper non-physical explanation for why that physical reality took on those characteristics at its the most fundamental level. So it's against that background, that sense of the space of possibilities. These numbers that get written in by hand, as physicists sometimes say, then those seem like they're not fundamental to the structure. They're just contingent features. They might have been otherwise. That creates a space of possibilities.
Yeah.
Even for a deterministic universe.
Everett's original model didn't have any variation of parameters when the universe is split off, so in that sense, it doesn't really solve it, does it?
Right, right, right. He's not addressing that. Yes,
Yeah.
yes.
So that's an extra hypothesis.
Yeah.
I'd say that evolution is relevant to certain arguments within this context, but not to others. For instance, all of the examples you gave of fine-tuning, I would say evolution is irrelevant to any of those because no stars form or there's a contracting universe or something like that. But then in the very next slide, the way that you presented the fine-tuning argument as producing, maybe you didn't say multicellular, although some people say that, an intelligent life with all these particular characteristics. Now those are things that are contingent on an evolutionary process, and so we don't know, for instance, the breadth of possibilities under which something like intelligence that we have could have evolved, and likewise life. So for instance, if you were to use some physical thing like the fact that liquid water is more dense than solid water, life as we know it is very unlikely in any other circumstance than that one. But we don't know whether there is another kind of thing that's like life that could grow.
Yeah.
Same thing for like silicon-based life instead of carbon or something like that.
Yeah. Yeah. So why did I not just go with the simple explanandum of or a special feature of life itself rather than the more enhanced? Well, it's just because suppose again our hovering angel, disconnected, having not even causally connected to the universe, just looks out and it sees a universe where there's life, but just very simple, single unicellular form of life, and there's no evolutionary possibility of even there eventually becoming other things. Would you say there had to have been a designer?
No, what I'm saying is that intelligence could have existed in a silicon-based life form. We don't know.
Okay, right. And so some of the fine-tuning factors, right, are tied to carbon-based forms of life, right? But not all of them, right? I mean, a lot of the fine-tuning factors are just saying, look, you just wouldn't get sufficient, differentiation of matter, spreading out of matter, and then coalescing of any sort, right? Yeah. So I think you're right. So if you want to say, since it's a state of ignorance, we don't know what the possibilities for life are beyond the particular variety we have, you should focus on those factors that are independent of our particular form of life. And we'd still have fine-tuning when you agree with that. Yeah.
Martin?
Hi, my question takes the form of a thought experiment.
Okay.
Imagine that there is no God. Science has once and for all proven that God does not exist, and a purely naturalistic account is sufficient for the universe's explanation.
All right. I just to quibble a little bit. You stated an impossibility. That science has proven that God doesn't exist. That's just not possible, I think. But, which is not to say that science could make, you might say, unnecessary. You're supposing any kind of inference, explanatory inference to the existence of God. Anything that you would seek to explain by a God, we can explain by science. Is that all you meant?
Well, no, I'm trying to figure out what would the universe look like that can be explained purely and sufficiently in naturalistic terms. You're saying that's logically impossible, but it's just to try and distinguish between a universe that needs God for its explanation and a universe that doesn't need God for its explanation, so that we can say, well, look at our universe, therefore, because of its characteristics, God is required for its explanation.
Okay, I was just quibbling with your saying science has proven that. I don't think
No,
science
it's a thought,
yeah.
it's a thought experiment.
Yeah, I now better understand what you're asking. You're saying, okay, so tell me, what could our universe be like that would give powerful disconfirming evidence? What might it have been like?
A universe that doesn't require God.
That doesn't require
for its
God.
explanation.
Well,
How would it
it's,
look different
because
from this
I mean, the
universe?
thing you have to realize is there's different sorts of considerations one might appeal to, and invoke God as an explanation of. Fine tuning is just one. So we're at a universe that did not involve, wasn't exquisitely fine tuned for life, right? Kind of boring, universe that expands only for a fraction of a second and then collapses into infinite, approaching infinite density or something like that, and just remains that way forever, or something like that. You might say, there's no interesting fine-tuning argument going on there. But you might say, there's still something. And so you might say, why is there something rather than nothing? That's a different kind of theistic argument, right? So certain kinds of theists would say, any kind of reality requires the existence of a necessary being, right? Otherwise we have brute unexplained contingency, and then you get into all what would such a necessary being be like. That's a very different style of argument. So my point here is that there are different kinds of considerations that drive different sorts of theistic arguments. They don't all track one another closely in that way. Design arguments appeal to special, particular features of our universe, right? There being, exquisitely organized things, as in Paley, or the fact that the fundamental laws of nature, on present knowledge, appear to be exquisitely fine-tuned for life. That's a design type argument. Cosmological type of reasoning, which I actually like, goes on in my book, just says, well, whatever there is, right? Why is there anything at all, right? And there's a lot. That's just a question. And then there's a whole lot of possibilities one could kick around to try to address that question. Should I even try to answer that question? Is it possible to answer? There's a whole lot to be said about that. But that's a different, that wouldn't require anything special because it's not empirically discriminating style of argument. It's purely philosophical.
Yes, in the back. Yeah.
But also listen to other arguments concerning fine-tuning, and they mentioned something about having an observational platform and an observer. Is that factored into your account, or can you factor that in?
I think you're referring to the sort of anthropic principle reasoning. Well, look, but I don't know if anyone else can speak to the specific language you're using. I'm not certain. That is, someone might say, we're
here. Therefore,
We're here.
carbon must have form. Therefore, the nuclear reaction must have had enough energy. Therefore, carbon has, the Hoyle reasoning must have had the energy levels just so. And therefore, if you go and look, you will find it.
And that's perfectly good reasoning.
Sure.
In other words, that's saying, you reverse engineer from what you've got to saying what are the preconditions
Using
on
the
that.
Anthropic.
So in the early stages of the universe, it had to have been the case that certain processes occur. That's perfectly good reasoning. But the conclusion to be drawn from that is, therefore, it's no longer surprising that there is life. That's where I say fallacious reasoning enters in. There's a legitimate and illegitimate forms of anthropic reasoning.
Yeah. Good. That's helpful. Yeah.
Well, I think that this second stage of reasoning inferience to a cognitive designer is fallacious itself, because Bayesian reasoning cannot be applied to unique events, and we can only talk about likelihood, as Elliot Sober presented it. That if designer exists, it's not likely that he or she will create chaos, but not vice versa. Not that if the universe with intelligent life exists, there is a designer, because it was just unique event, and not any probabilistic reasoning applies to this.
I play poker with Jeff.
Yeah.
It's a unique event. I deal myself a couple of unbeatable hands. And I say, Jeff, why are you pointing that gun at me? And he says, that was really unlikely and improbable. And I say, but Jeff, this is a single case. What's this notion of probability you're operating with here? It's just a one-off event. Something's gone wrong. Right? He's right to be suspicious.
It's just a metaphor, and I prefer you to explain it in this symbolic language. These letters and probabilistic slide with stage
Yeah.
2.
Maybe it's going to take us a while to get back.
I think actually. Okay. There we go. Here we go. Okay. So what are you objecting to?
I'm objecting to, if there are n possibilities that are equally likely, then probability of which is 1 over n. But we don't have n possibilities,
Right.
because we don't know any other universes, and this is it.
Jeff, you're wanting to make a
No,
comment
can
on
I
it?
just jump in? I think what you might be saying is, in this universe, the numbers you've given us, 10 to the minus 40, refer to precisions.
Right.
But how do you move from a precision to a probability? Because we don't have other universes, and we don't know the conditional probabilities that you get a particular precision.
Is that
Yeah,
that's a
yeah.
satisfactory gloss on what you're saying? Yeah. So you don't know. Is it that you're saying, look, we don't know that that it's possible that there have been universes that take on the alternative values? Or is it that we don't know the...
We don't know what the probability distribution would be
Right.
for an
Yeah,
individual parameter,
exactly.
I think.
So the numbers are really small, and intuitively we say, wow.
Right.
Yeah.
But those numbers are not probabilities,
Yeah,
they're
right.
precisions.
Yeah.
Okay.
So we really can't say what is more and what is less probable, and you told that we can.
Yeah, so the person giving this argument is suggesting or supposing that the natural thing to do in the light of this data is to treat on the chance hypothesis that whatever the fundamental physical facts are, they are the way they are for no further deeper reason. They just are the way they are, right? On that chance hypothesis, we should assign a probability we should treat them as all as equally likely, right? And so we should assign our probabilities that way. Now, is the thought that that's a really unreasonable or rash thing to do because there might be, or is it the claim that that just doesn't even make sense, that probability just doesn't have application? Any notion of probability to single case events, which I'm skeptical about. Yeah, I mean, right.
This is a,
quantum
this is a
mechanics.
I suppose that one question might be, is are the probabilities we're dealing with here mathematical or physical probabilities, or are they epistemic probabilities?
Right, right. Well, I would say it would either be just absolute metaphysical probabilities,
Yeah.
which are more, a special case of which would be a physical probability, say, in quantum mechanics. Or, if you like, you could say they're epistemic. As best we can tell, these are the probabilities we should assign. And we often engage in, and I think most fundamentally when we do probabilistic reasoning, it's based on our current knowledge, right? We don't think we directly glean the absolute probabilities. We're going on the basis of considerations as best we can judge.
And probably that's why you've called it inference to the best explanation.
Yeah.
But it's a kind of abduction and not probabilistic reasoning in Bayesian fashion. So I think it's the reason why it's fallacious.
All right. Well, we'll just have to follow up further on this. I'm not persuaded of
Whether
that.
that makes it fallacious or not is, I think, how
Yeah.
good. Yeah. Good. Right.
What about ideas like the Copenhagen interpretation, or like even Penrose has these ideas like orchestrated reduction and stuff like that? How does that
Explain what you mean. What specifically? What's the bearing?
Well, just the Copenhagen interpretation of
Right.
quantum mechanics that you need this observer to turn from a potential wave function to an actuality.
Yeah.
And,
This argument isn't turning on quantum mechanical, indeterminacy or not. It's not. It's rather it's saying it's sort of operating from a presumed, place where we know we're not, which is a final physical theory. right? And it's making the assumption when we get there, based on what we currently know, it's likely that some fine-tuning will persist, and that's something we should talk about, right? Right, as things now stand, there are various constants. And it has nothing to do with physical indeterminacy. So that could be so. Suppose Copenhagen interpretation is right. You have some weird, observation event. What exactly is an observation? That's always, does it have to be a conscious human mind? It can be a detecting device, right? There are notorious obscurities with that idea, but there has to be some observation event that introduces indeterminacy into an otherwise deterministic evolving wave function. Okay, and whatever the fundamental physical facts are of the universe that fix that fact as being a fact about reality, we then, that's what we're now seeking to explain. We're saying things didn't have to be just that way fundamentally. They could have been other ways. But they had to be pretty much the way they are, apparently, for there to be life. So I don't think that it matters. But this is, do we not have time? I was just going to say, I'd be curious. I think there are a couple weak points in the argument. One of which is empirical, right? You say, well, we're not done with physics, and some things that have looked fine-tuned give way under deeper theorizing, and they fall away. You no longer have these large constants, and it's likely that will be true for many of these so-called constants. Physical theory is likely to get simpler, right? So what do you make of that? I know that a number of scientists have said it's very unlikely that all forms of fine-tuning are going to fall away. This is partly why multiverse theorizing, if you restrict yourself to a single case universe, certainly. While some of these factors are likely to fall away, there are too many of them, independent parameters, that's likely. But are you just unmoved by that, saying, where does that notion of it's unlikely to be the case? I'm curious how scientists react to that.
Yeah, I think that idea is an important one, and you left it out of your presentation, which is this final theory explanation. And I think it hinges around this very last point that you just made, which is how many fine-tuned parameters are there? Paul Davies in his latest book talks about 30 or so.
Right.
Martin Rees has this book, just 6 numbers. He says just 6 numbers. One of them being the 10 to the 40, which is the ratio of gravity to electricity. One of them is the 10 to the 120, which is the dark energy content of the energy. Anyway, so to him, there's a small number of really fundamental parameters. Many of the others are related. And then the claim is, when we go further in theory, perhaps we will find some connections between these numbers, and in the end it is just one parameter or one number or just one principle. And the final theory will explain to us why each one of these is with the precision that it has, and then in the end it is all elegant. Now, my view, I would be very happy to hear your point of view. My view is, in the end you will always have some principle to explain something, which relates to your very first slide, which is at the edge, or at the, what did you call it, the outskirts or something? At the limits. At the limit. So you will have something at the limit, even if physics is so successful as to put all of this together into a beautiful construct, and then we are no longer impressed by, look at this parameter 10 to the 40 and look at this parameter, but in the end, you still have something to explain. And my contention is you will never be able, they say, by the way, they don't give up, they say, there will be something, the self-consistency, beauty, I don't know, something that will tell us that this is the theory, that this is why it is the theory. But in the end, by the way, I just wanted to add something about the multiverse. The reason why I, quote, dismissed the multiverse yesterday is not because it is speculative. I have nothing against speculation. People speculate all the time about all kinds of things, especially when it is so mathematically elegant and rigorous. I mean, it's rigor, it's elegant, beautiful, and it produces a landscape, as Susskind calls it, a landscape of possibilities. Oh, this is great. If it is not testable, then they cannot present it as a scientific explanation of the fine-tuning. Now, call it, mathematical games, put it in Scientific American or whatever, beautiful, great. But to present it to me as, the explanation to fine-tuning, and thus, as Susskind does and others, do away with the design and the creator, I say, no, wait a minute, you can't do that.
All right, just quick comment. I mean, first on that last, I attended a conference on cosmology in Beijing. This big international conference, a lot of big wig cosmologists were there. And I was surprised just sociologically as a philosopher, just along listening to all these talks on current developments in string theory and so forth. And you just had two camps, they were shouting at each other for 3 straight days. The sort of old guard, I would say, we're empirically minded, our theories need to be testable, right? And people were all enthusiastic, they were literally shouting, getting really angry with each other.
Burton Richter, a few years ago, Burton Richter, a very famous particle high-energy physicist, expressed it that to his idea, many of the developments in the latest developments in physics, and he was referring to these types of topics, gave him the flavor more of theology than of science. Sorry about the insult.
But I want to respond to the first thing you said about the numbers. I want to say something about the numbers. We have to be careful of not indulging or not falling prey to, as one writer puts it, the imperceptible transition from pious hope to foregone conclusion. That is, it might be a pious hope that one day all fine-tuning will fall away. And so, yeah, maybe. Right, and this argument is vulnerable to that sort of consideration. So there has to be a certain tentativeness. So after you run the argument, then you say, yeah, but how likely is it that the fine-tuning is going to remain? Then you have to conditionalize on that somehow. And so you scale back your confidence. But still, that doesn't mean it's of no value. As things now stand, it doesn't look especially likely that we're going to get all the way, all fine-tuning is going to fall away. But then you say, well, there still might be something left to be explained, but it might not be a fine-tuning design argument. Then we're into cosmological reasoning about existence itself, which I'm happy to, but it's a completely different kind of argument.
Yeah. Jeff has a question again. I'll give you another go.
I want to go back to the very beginning of your talk where you made the distinction between God of the gaps and God at the edge. And it's a distinction that makes sense to me. I think it's important. As you characterize God of the gaps, it involved violating the regularities of nature, and then your Drummond quote affirmed that. And there's real theological problems with that, as Drummond suggested. But many of the criticisms yesterday of God of the gaps were not theological. They were epistemological and involved the risk of this move. And in his criticism of God of the gaps later, Bonhoeffer actually suggests a model that's very much like your model, the edge. He talks about as the domain of science grows, if we locate God outside the domain, God continually shrinks. And so what would your response be to people yesterday saying, well, no, the real problem with God of the gaps is that it's just risky, that as our understanding grows, our warrant for belief in God diminishes.
I'm not sure by you bringing in Bonhoeffer what your question is. That is, I would say about, are you worried that, well, if we agree that we have to respect the integrity of nature, we ought to treat that as, we ought to set our face against the idea of looking for intervention, then where's God? I say God's everywhere, right? He's every single event.
That's not my word.
Okay.
And actually, I thought the worry yesterday, I should let these people speak for themselves, was not just that. It was with the risk of locating God in what we can't explain. And that problem exists whether what we can't explain is an interposition in regularities or the edge of regularities. That risk exists in either program.
Yeah, so I'm not happy with it's risky, therefore don't do it. Science engages in risky, it's fallible. Science is fallible, but we put more or less degrees of confidence in theories based on evidence, but recognizing that it's provisional. So I'd say not. So my problem with God of the gaps reasoning is not risky so much as it seems to go contrary to a fundamental presumption that the scientific enterprise works upon that actually has that also is theologically well motivated. That this world is the product of a infinitely wise creator, right? He doesn't need to kind of, it's like Newton, right? We talked about Newton. Yes, of according to his calculations, turned out he just did his calculations wrong, I guess. Laplace, it wasn't new data. Laplace just said, you know, he got the numbers wrong. So he thought, you know, the planets would go all wobbly at a certain point. God has to intervene. Leibniz ridiculed him on theological grounds. You know, they were great enemies. And he said, you know, it's like a clockmaker that has built a faulty clock, and he's got to go in there and fine tune and take it apart, you know, every now and then. He calls into question the wisdom of God with that. And Leibniz says we should appeal to miracles. God acts in miraculous ways not to supply the needs of nature, but of grace, right? So yeah, I mean, I guess what I'm groping after is I take it to be a priori implausible. If any particular hypothesis of the world largely functions with causal integrity, and then except for this little spot over here, it's special creative act of God only. I mean, I'm talking about a miracle. I'm talking about something needed to fundamentally sustain the world. That's a priori improbable. It's not impossible. I could have reasons that we don't recognize why it really is compatible with his infinite wisdom to do it that way, but it's just, we should treat it as a priori. This is an epistemic probability, right? It just seems a priori unlikely, dubious, right? And give it, and it's a bad thing for religious believers to be engaging frequently in a priori dubious religious hypothesizing, because if they are a priori dubious, they're probably going to turn out to be wrong most of the time, and then they bring religious belief into disrepute. People think it's bound up essentially with that kind of theorizing. That's my problem. So it's not riskiness per se. There's what's the phrase you use in investing? Something risk, calculated risk, or there's a sort of, you have to take risks. Life involves risk. Walking out the doorway involves a certain element of risk, but it's a reasonable risk versus rash riskiness.
Just a brief addendum to that. I think that the concept of the expanding science rendering the using God as an explanation vulnerable or risky is greater in the case of the typical God of the gaps, because we're using the current state of science. But you are not doing that in your program. You're positing a theoretical limit to science.
Right.
So something that science can't even in principle go. And so if that were to expand, that'd be a much less likely thing, unless it would suggest that you made a mistake.
Right, and I think the person who advocates this style of reasoning should say, we might be wrong. I'm just going on, it seems unlikely that all fine-tuning will fall away, so I'm tentatively endorsing a line of reasoning saying there's some degree of confirmation of cosmic design based on this. If it turns out I'm wrong, fine, right? That's a very different posture from the person who says, yeah, but you can't explain that, you scientists, sort of thing, biological life, that's still going to be a mystery. That's sort of saying, you can't do this. Yes.
Martin again.
Hi, I'm a psychologist, so I know even less about physics than biologists, but my question is, in the history of physics, is it not the case that sometimes the maths to support the theory has come first and then the empirical evidence comes later? So given that some physicists argue the mathematics is consistent with multiverse theories, that we shouldn't be so quick to dismiss them.
Can we get that question again? I think it's my voice.
Sometimes in physics, maths precedes the evidence, the physics, and maybe maths here with multiverses is elegant or whatever, and
maybe fruitful in the end.
Yeah, maybe fruitful in the end. I think is the question.
This has to be tested at some point.
Yeah. But
I'm perfectly happy with that. I don't want to impugn multiverse theorizing at all. I find some multiverse ideas really beautiful, actually. I actually think, I'll just throw this out, independently of physics, just as a philosophical argument, I argue in my book, chapter 5 of my book, that if God exists, it's very likely that at least a countable infinity of universes exist. I think there's theological reasons to think about it. So I love multiverse theorizing. I think it's true.
that raises the issue.
But that's a separate. That's not
how many universes do you need to guarantee?
Yes.
I mean, in my book, I have a chapter saying, well, most multiverse theories only give you a countable number of universes. Well, I mean, the possibilities are uncountably infinite and so on. And, you know, to guarantee, you know, it gets you into all kinds of.
Yes.
But I think with Max Tegmark, you know, he says that all possible mathematical structures have physical existence.
Right.
It's his ultimate multiverse. And to me, it seems that's the only one that will actually do the trick for you.
Yeah, but, well, I'll just say this about Max Tegmark's idea. I don't know that I fully understand it. I did have a chance to chat with him about it. He seems to claim, I can't believe that he really thinks this, but he seems to claim that physical realities are mathematical entities, some kind of Pythagorean sort of thing. All reality is mathematical. Our universe is a mathematical structure. Not just it embodies a mathematical structure, it is of identity, okay? And he says that all possible mathematical structures exist, and that's all of reality. And I think he's lacking in that robust sense of reality that Bertrand Russell complained the idealist failed to have.
Yeah, he does that. He somehow ontologizes all the mathematical structures. That's right. Well, we've got a few more minutes if anyone wants to. Yes.
Regarding the definition of the word fine-tuned universe, can we say that it is limited to certain dimensions? That the universe we know is fine-tuned in certain boundaries, because on the level, as I asked yesterday, Professor Catherine, on the small scale of quantum realm, we can't say it is fine-tuned. We have reason to say that we've got the uncertainty principle, and we have sort of chaotic dimension realm, you can say. So on a higher scale, we have the Newtonian laws applicable for the universe we have, so we can call it fine-tuned. So we can go for a larger scale, for maybe we need a set of new physical laws. So can we say that the universe or the world is fine-tuned on a certain boundaries or limits?
Yeah, and the fine-tuning features that people point to are sort of parts of cosmic structure, you might say, right? The large-scale structure and constitution of the universe. And I don't know, sorry? But not only.
I mean, some of the more famous fine-tuning arguments are about, for example, nuclear resonances, which are very, very quantum mechanical. Okay, so I think I wouldn't actually agree with your initial hypothesis, which is that fine-tuning is at the big scale. I would say, you know, when you talk about fine-tuning of the laws of nature, these are to do with the forces. These can be just as small scale as you like.
Okay, but I'm trying to understand. You're wanting to say somehow you were skeptical about fine-tuning applying at the level of quantum mechanics, and why is that? Because of the indeterminacy? Is that the idea that you know, if we reject Everett's idea that all possibilities are realized, and we just say, you know, we followed one path through this space of quantum mechanical possibility, which is vast, you know, to get to where we are now. Not all of those possible outcomes would have involved life. Is it something like that? Was that the thought?
Yeah. Well, if I ask you, define the word fine-tune. So this definition, whatever it is it applicable for all the different layers of the universe? We know a very small scale layer of
Ian is saying the answer to that is yes. I mean, the term fine-tuning, it's supposed to be a neutral term. It was coined by Brandon Carter, I think, who did not believe in a fine-tuner, right? But it's just the idea that there are apparently arbitrary or contingent constants involving very large or inverted, very small ratios that had they been different in anything but very, very minute ways, and then you sort of program that into a model of the universe, life would not have been able to appear in the fullness of time. That's the idea. That's what the term fine-tuning is supposed to capture.
Maybe he's referring to the fact that the examples that you gave were largely gravitational examples.
Yes.
But I'm pointing out that there are many other examples that people refer to, which are to do with the strengths of various other forces, the strong force, the weak force, electromagnetic force, etc.
Which are the
Well, that was the Hoyle one.
And that these are just as quantum mechanical as you like, so that the arguments about fine-tuning go all the way down through the different scales of the universe to as small as you like as well as big as you like. That's what I think.
Thank you. Well, I think it's approaching lunchtime, and I think we should give Tim a big round of applause.